Okay, these notes today are on something called combining like terms, page 31 or 41 from your toolkit. You should have that page open, and it is the section at the top. So combining like terms has to do with working with the algebra tiles like we have been. And it's just about matching up the things that are the same. So let's start right out and say, what are like terms? Like terms, when we're talking about the tiles, are the same size and shape tile. Those are alike. When we're talking about just looking at the values, variables, and numbers, it is the same variable and exponent. If there's an exponent, it has to be the same. So x and x squared are not like terms because they don't have the same exponent. X's are the same as x's, x squareds are the same as x squareds, right? So that's kind of two different ways to look at how do you identify a like term. It's either the same shape and size when you're looking at tiles, or if you're just looking at the numbers, the terms, same variable and exponent, and numbers are just numbers. So what's the big deal about like terms? Well, this, you can add and subtract. Like terms to simplify the expression that you have. Why do we want to do that? Well, it means that we can write less, right? So let's look at an example, and then I'll talk about how this relates to what we were talking about with the area of the algebra tiles. And then we also need to kind of hit on how do we find the perimeter. So if we had this list of terms, 2x plus x squared plus 3 plus x plus 5. Okay, that is a list of terms, not in order, not simplified. So what we want to do is match up the like terms so we can put them together. The easiest way to do that is to mark them and then rearrange them so the like terms are together. So I'm going to go through here and go, okay, well, I have an x term there. I have an x term here, and I'm going to keep that plus in front of the x because it goes with it. The sign, the add, subtract, whatever in front of the term sticks with it. So here I have a plus x squared, I have a plus 3, and a plus 5. Okay, so I put a box, I underlined, I circled. Now, if you have a bunch of handy dandy highlighters around, instead of doing that, you could highlight them to match, right? So here's our x term, here's our x term, here is our x squared term, and here are units. So the things that are matching color-wise are matching terms. So now I'm going to rewrite this, x squared plus 2x, so that the like terms are together. Plus 2x plus x, and if you like, you can even cross them off as you move them. I did that one, plus 3, that one, plus 5. So now I've rewritten everything, but now they're grouped. So the x squared doesn't have any other x squareds, so it stays. 2x and x are like terms, same variable, right? They're both x. So we can combine those. How many do I have there? Well, I have 3, right? 2 and what doesn't show in front of the x's, that's actually a 1. So 2 plus 1 is 3x, plus 3 plus 5 is 8. So there is my simplified expression. That is simplified or written in the fewest number of terms possible. And that's all we're trying to do. That's what combining like terms is all about. Okay, so what we've been working on with the algebra tiles, just starting last week, this is what we're trying to get to, the ability to combine like terms. Now, we talked about area of the tile model. Like when we have this group of tiles here, for example, what is the area of that group of tiles? Well, the area, remember, is just the tiles that you have. The tiles you have, if you just list them, that's the area. So in this example, we have an x squared. I'm looking again at this one right here. I have 2 x tiles, and I have 1, 2 unit tiles. So that would be the area of that group of tiles. X squared plus 2x plus 2. Okay, now perimeter, we haven't really talked about this, but perimeter is the distance around the outside of the tiles. What you want to do is this: label the outside edges. I'm just going to put label the outside, then add, and I'm going to abbreviate, LT stands for like terms. So this one, and I don't know, we wrote the distributed property stuff on the bottom. If you're starting to run out of room, you can do that kind of over on the side a little bit. So this is the one right here that we're going to do the perimeter on. For the perimeter, the tiles do need to be touching. Okay, so I'm going to first kind of highlight these so I can see the difference. So this side, this side, this side, this side, those are all the same. Right? Those are the same length, and they are already labeled. I'm just going to make it a little bit bigger. There's an X, there's an X, there's an X, there's an X. If you don't remember those, all you have to do is look on the previous page, page 30 or 40, and we labeled the edges of those tiles, right, already. So those long edges are X's. The short edges, that's a 1, and the sides of the unit, those are 1s. So label them all. So now we know what they are. Perimeter is always, no matter what you're looking at, distance around the outside. So now we want to write down what we have. So the perimeter of this shape is X plus, I'm going to write it that way, X plus X plus X, 1, 2, 3, 4 X's plus X. Now for the units, I think you get that we could count them instead of just write all those 1s. Instead of going 1 plus 1 plus 1, we can go 1, 2, 3, 4, 5, 6 units. So plus 6. Okay, so that is a correct perimeter, but I can do what I wrote up here about combining like terms, that is add them together. And all of those X's, X plus X plus X plus X, those are like terms. Remember, in front of each one of those X's, it's really a 1. So there are 4 of those X's, 1 plus 1 plus 1 plus 1 with the X, 4X, plus the 6 units. So the perimeter of that shape is 4x plus 6. Those are the measurements of the outside edges. Some of them measure 1, some of them measure x. Now, the good news is when you're talking about algebra tiles, the outside edges are either x or 1. There is nothing else. For the area, you might have some x squareds, but for the perimeter, they're either 1 or x. And again, previous page, we labeled the edges of those tiles, so you should be able to look at it right there.